Greatest common factor time. Yes, I know you've seen it before with numbers, but you've never seen it with variables. And that's what we're going to look at. We could go back and use the factor tree for numbers all we want. That's great. But the whole idea is we want to break them down into factors, and we want to determine the greatest common factor for them all. Well, take a look at this, because we've never done this with x's before or y's or whatever. GCF for a set of variables means get the one with the largest power. What do I mean by that? Well, look at this. Largest power common to all of them. Look at x to the 4. Is this not x times x times x times x? Look at x cubed. Isn't this x times x times x? Look at x9. Oh my goodness, I'm going to go forever here. 1, 2, 3, 4, 5, 6, 7, 8. Oh my goodness, and 9. It's kind of interesting to see. I want to show you something. Look, there's 3 here. There's 3 here. There's 3 here. Even though we wrote them out in big, huge, broken down, expanded form, whatever you want to call it, notice that there's 3 common to here, 3 common to here, 3 common to here. Look at that. X cubed was common to all 3. There's your GCF. It just makes sense. Look at this one. This one says x times y times y times y. I don't know why. I guess we'll know why soon. Okay, there's x times x times x times x. That's this guy. 2 y's, y and a y. Look what's common to both. Notice this is 2, this is 3. If you think about it, only 2 y's are common to both. Look at this one now. This says x and 4 x's. Only 1 x is common to both. Do you see the pattern yet? So this is like saying there's 1 x and 2 y's common to both. There's your GCF. That's how it works. Now, let's throw some numbers in there. Oh, right. 5, m times m. Look at this, 15, which you can break down using a factor tree. 5 times 3. So this is 5 times 3, m, and n and an n. So let's think for a second. What is the greatest number common to both? Well, yeah, 5. How many m's? This has 2 m's. This only has 1. The only thing that that is common to both is 1 m. Look at this. This has 1 n. This has 2 n's. Guess what? It only has 1 n. And oh, I forgot to write it out here. Forgot that last n. So it only has a common n here and here. So look, you got a 5 that's common. You've got 1 m that's common. You have 1 n that's common. That's it. Okay? So GCF, which means the greatest common factor, it actually has a lot to do with the one that has the least number of representatives. Think about it. This is x to the 3. This will have more than x to the 3. This has way more than x to the 3. X to the 3 is your weakest, kind of like saying your weakest link. See what I mean? Look, this has an x. This is 4 x's. The only one that's common to it is x. This has 3 y's. This has 2 y's. They have 2 in common. There's your GCF. Look at this one. 5 and 15, you know that a 5 is common to both. But this is m squared and this is m. So that means you only have the weakest link, m common to both. This has 1 n, this has 2 n's. You only have 1 n common to both. That's the best and easiest way to do GCF factoring.